Welcome to video T.3C, an application problem with rotations. Okay, so here's example 3. The London Eye observation wheel has a radius of 67.5 meters and takes 30 minutes to make one complete counterclockwise rotation. Okay, I've got a diagram over here. A car starts at position 67.50. What are the coordinates of the car's location after 5 minutes? Round to the nearest tenth. Okay, so the car is starting right here, basically on the ground at 67.5, 0, and then 5 minutes elapses. It's going counterclockwise, and it's ending at a coordinate over there, x, y, and we want to know what the coordinates are. Okay, so this is going to be a recall of trigonometry from Algebra 2. If you've forgotten it, I'll do a quick brush up. So what I did is I just drew a right triangle representing this car's coordinate location, and x is this distance, that's the x coordinate there, and y is this vertical distance, that's the coordinate there, and I'm calling this angle right here theta. Okay, and then remember in trigonometry, once you've got your reference angle, we're going to label the triangle. So opposite the 90 degrees is always the hypotenuse. Opposite the reference angle is the opposite, and then the adjacent is the last one. Okay, and then recall we've got SOHCAHTOA. Okay, and I'll go over that more. So first step, we want to find the measure of this angle, then we'll use trigonometry to solve the problem. So what I'm going to do is use a proportion. Oh, it takes 30 minutes to make one complete rotation of 360 degrees. Now I'm going to set that equal to 5 minutes over theta degrees. Okay, so to do that, I'll just cross multiply. So I'll get 30 minutes times theta equals 5 times 360. I'll divide this by 30, divide that by 30, and then that's going to be a 6, 365. So theta is going to end up being 60 degrees. Okay, so then I can put 60 degrees right in there. And once I've got a right triangle, and I have a known angle 60, the hypotenuse I know is 67.5. I can use trigonometry to find the adjacent and opposite sides. So I'll do that next. So recall that the cosine of theta, and in this case we know theta to be 60 degrees, is adjacent over hypotenuse. Again, SOHCAHTOA. C is for cosine, and then A and H, adjacent and hypotenuse. Let's fill in the numbers I know. The adjacent I don't know, it's x. The hypotenuse I do know, it's 67.5. Okay, I could multiply each side by 67.5 and get x equals 67.5 times the cosine of 60 degrees. I'll do that calculation last. To find the y-coordinate is associated with the opposite side, so sine of theta equals opposite over hypotenuse. Again, so sine opposite hypotenuse. So let's fill in what I know. The opposite side I'm looking for, that's y. The hypotenuse, once again, is 67.5. And again, I knew the angle theta to be 60 degrees. So I can multiply each side by 67.5. So y equals 67.5 multiplied by the sine of 60 degrees. Okay, at this point, just use your calculator, either the TI-84 or your scientific calculator. If you use the graphing calculator, make sure you're in degree mode. It defaults to radian mode, so to check, you can just hit mode and look to see that degree is highlighted. Mine is. Okay, so I'll just perform this calculation. 67.5 times the cosine of 60, and I got 33.75. It said to round the nearest tenth. I'm going to call that 33.8. Then I'm going to go 67.5 times the sine of 60, and I got 58.5. Sorry about that. Okay, then I'm going to answer the question. What are the coordinates? I'll just write the answer over here. The coordinates are 33.8, comma, 58.5. And that would be my answer. So there you have it, an application problem with rotations and a quick review of trigonometry.